Anyway, welcome. So what we're going to do right now is I'm going to create a series of videos that are going to cover the Algebra 1 Common Core curriculum, and it's going to prepare you, or actually it's going to leave you better prepared or prepared beyond the Common Core to take the Common Core Algebra regions. Okay, so I'm gonna get started. I'm gonna start from scratch. Okay, from the beginning, from the core. That's it, right? So let me get my stuff together. Now, let's see how we're going to start. We're going to start with, let me see. Not this, not that. Let me see the diagram below. Oh, that's geometry. No, it's not happening. Okay. Little guy, you need to go away. Oh my god, this is a mess. Okay. I should have done this before, right? Okay, here we go now. Oh, okay. So we're going to start with adding and subtracting fractions. So what we're going to do is we're going to look at a couple of fractions and see how do we add them and subtract them. Now, before we do that, I wanna review reducing fractions. So when you're going to reduce a fraction, okay, you see this thing, right? No, it doesn't write. Alright. Let me see, this one writes. No, it doesn't write. Let me see. This one writes. Okay. So let's say we have the fraction 9/6 and we want to reduce it to its simplest form. So what we do is we are going to find a number by which both numerator and denominator can be divided by. So in this case, let's see if I can do division by 2. Can 9 be divided by 2? No. 6 can, but 9 couldn't, so you can't reduce it because you have to be able to do top and bottom. Let's try 3. Can 9 be divided by 3? Well, 9 divided by 3 is 3. Okay? Now, can 6 be divided by 3? Of course it can. 6 divided by 3 is 2. And now, this is your fraction in simplest form. And why do I say simplest form? Because if I try to reduce this, the lowest number I can divide by is 2/2. Okay? But I cannot divide 3 by 2. So I can divide 3 by 3, but I cannot divide 2 by 3. So, I'm going to show you something. Something is bothering me right now. No, get off here. Get over here. Yes, that's you. Goodbye. Okay, no, you're not getting this. Okay, now let's try B. It says 14/56. Well, let's see. 14 is an even number. Can it be divided by 2? Now, Becker, why can't you divide by 1? Well, if I divide by 1, they won't change ever because anything divided by 1 is itself. So then I have to start with 2. So remember, you're dividing top and bottom. Now, why do you divide top and bottom by the same? Because you want to keep the fraction the same. Now, I'm going to say this and it might sound weird to you. You are actually dividing by 1. What? Yes. For example, watch this. Can I divide 14 by 2? Yes. And I get 7, right? Let me put it over here. 7. Can I divide 26 by 2? Well, 26 divided by 2 is what? Sorry, not 26. 56. 56 divided by 2 is 28. Okay? Now, this is what I divided by. I divided by 2/2. That's what I divided by. I divided this by 2 and this by 2. And look, 2/2 is nothing more than a fancy version of the number 1. Like 3/3, fancy version of number 1. 4/4, because 4 divided by 4 is 1. 5 divided by 5 is 1. And you know what I'm saying? So then, is this in simplest form? Let's check. 7 is a prime number. a prime number is a number that can only be divided by two numbers, two different numbers, itself and 1. So you may be asking, is 1 a prime number? No, 1 is not a prime number because it has to be divisible by two different numbers, itself and 1. And 1 and itself are the same thing, so no, they're not two different numbers. Anyways, going back to this. This is a prime number, so it can only be divided by 7. So then I look at the bottom and I said, can 28 be divided by 7? 7 times 4 is 28. Oh my God, yes, it can be divided by 7. So then when I divide, look, and I'm dividing by a fancy version of 1. 7 over 7. So this is a fancy version of 1. 7 divided by 7 is 1. So if I divide this by 7, I get 1. If I divide 28 by 7, I get 4. Make sense? Okay then. So 1/4 is the simplest form of 14 over 56. Okay. Let me see if I can make this a little larger. Yeah, okay, that's it. So, Kobe, leave me alone. Alright, 25 over 100. 25 over 100. Well, you don't need to see my face, you need to see the problem. So 25 over 100. How do I simplify this? Well, can I divide by 5? Yes. This divided by 5 is 5. Can I divide this by 5? Yes. So 25 divided by 5 is 5. 100 divided by 5 is 20. Can I reduce this anymore? Yes. 5 divided by 5 is 1. 20 divided by 5 is 4. So this is 1/4. Nice, right? Alright, wait. Oop, caught you. Okay. Now, could I have done this in a different way? Could I have done this part? Let me see, can you see that? Can you see the 1/4? Well, if you can't, oh yeah, you can, but just in case. Okay. So, could I have done a different division by 1? Yes, I could have divided by 25 over 25. Watch. 25 divided by 25 is 1. 100 divided by 25 is 4. So, there you go. I didn't have to go all the way. But that's only if you are confused about it. If you're not confused about it, then go ahead and divide by the largest number that both of the numerator and the numerator can be divided by. Okay? Alright then. So this ends our introduction in regards to reducing fractions. Now let's talk about adding and subtracting. See? Yep. Okay, so back to the lesson. For example, how do you add or subtract fractions that contain the same denominator? Well, if they have the same denominator, that means that they are part of the same thing. Okay? So all you have to do is put together the parts and you get the total. In other words, to add, and you might want to take notes, to add fractions containing the same denominator, add the numerator and copy the denominator. So 1 plus 3 is 4, plus 2 is 6. 6 over, you guessed it, 6 over 2. Now we want our fractions to be in simplest form. So what we want to do is, we want to reduce. Well, we already went through the reducing part. And remember, let's try to see if they both divisible by 2. So can 6 be divided by 2? Yes. Can 2 be divided by 2? Yes. Which is 1. So our final answer is 3 over 1. Now 3 over 1 is what we call a fraction, a rational number. 3 over 1 can be simplified as, or sorry, not simplified, but rewritten as 3. Got it? Alright then. This one. Look. Same denominator? Yes. So 7 plus 4, 11. Plus 3, 14. So it's 14 over 5. Got it? Okay then. Now let's try example number 2. So let me see now. Let me just move a little bit. Okay, you could do it, Becca. You're nice. Alright, so let's see now. Do they have the same denominator? No, they don't have the same denominator. But then guess what? We're going to make them have the same denominator. These two fractions are part of the two different things cut differently. This is 3 out of 2, this is 4 out of 3. So let's turn them into equivalent fractions. Yes, I know. If you're coming from middle school, you will say, but this is an improper fraction. I need to change it into a mixed number. No, stop. This is high school. You don't need to change it into a mixed number. We'd rather deal with fractions than with mixed numbers. Trust me. Okay, so let's see now. How can I make these two right here, these two denominators, equivalent? Well, look at the times tables. On the times tables, tell me where is the first number that when you start multiplying on the times tables, 2 times 1, 2 times 2, 2 times 3, 2 times 4, and 3 times 1, 3 times 2, 3 times 3, where is the first common number that they have? Well, let's see. This is a quick example. So I have the 2 and I have the 3. So let's start with the times tables. 2 times 1 is 2. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8. 3 times 1, 3. I'm sorry. 3 times 1 is 3. 3 times 2 is 6. 6. 3 times 3 is 9. 3 times 4 is 12. And I can go on. I know that 2 times 6 is 12. I know that 3 times 4 is 12. They both have 12 in common. But that's not the idea here. The idea is to have the closest, the smallest number that they have in common on the times tables. So let's see. 2 times 3 is 6. 3 times 2 is 6. I found it. So that means that I can make these two denominators 6's. What is the process? Well, the process is as follows. By what do I need to multiply the 2 to become a 6? By 3. Okay. So then, what happens is that you gotta keep the fraction the same. So you're going to multiply by a fancier version of the number 1. 2 times 3 is 6, right? So that means that what you did to the bottom, you also have to do to the top. So let's see. When I multiply this by 3 over 3, I get 9 over 6. I multiply this by 3, so I have to multiply this by 3. Now let's go on to the next fraction. I need to make these 3 a 6 because that's what they have in common. So 3 times what is 6? Right, 2. So I need to multiply the 3 by 2. But then if I do that, then I gotta do it to the top. Okay? So plus, and then 3 times 2 is 6. 4 times 2 is 8. And now they have the same denominator. That means that I only need to add the top. 9 plus 8 is 17. So my final answer is 17 over 6. Beautiful? Okay, let's try with this one. So I have 4, 2, and 8. Talk to me, baby, talk to me. Where is the first number that you see these 3 numbers, having in common on the times tables? Well, let's see. 4, okay, definitely is not 2, because I have an 8 over here. Definitely is not 4, because I have an 8 over here. And I don't know if it could be 8, the common denominator. So what I have to do is look at the times tables. Let's see. 4 times 1 is 4, 4 times 2 is 8. Oh, okay, 2 numbers in common. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. Oh, I can make all of them 8. Oh, yes! So then, watch the transformation. Something magical is happening here. To get this to a number 8, I need to multiply by 2. So I gotta do the same thing to top and bottom. So let's see. 4 times 2 is 8. 3 times 2 is 6. Plus. How do I make this 2 and 8? You gotta multiply by 4. So 2 times 4 is 8. And then 3 times 4 is 12. So far so good. And now guess what? I don't have to do anything to this 3 over 8 because the denominator is already 8. So plus 3 over 8. They are all over 8 now, and now all I have to do is add the top, because that's how you add fractions with the same denominator. So 8, 8, 8. So then 6 plus 12 is 18, plus 3 is 21. Final answer, 21 over 8. Then we could try to simplify. How? Well, see what can I divide both top and bottom by to see if I can reduce it. Can I divide by 2? No. Yes. Okay, so it cannot be done. Can I divide by 3? Yes. Can I divide by 3? No. Can I divide by 4? No. Can I divide by 4? Yes. Can I divide by 5? No. By 5? No. 6? No. 6? No. 7? No. 7? No. 8? No. 8? Yes. I reached 8 already. So basically, this is the simplest form of that fraction. I cannot reduce any more. And that's it. So let us see what else do we have. Okay, so you have independent practice right here. So let's see how it goes. Same denominator? Yes. So then add the top. Cannot be reduced. You could try it. I already showed you how. You could try it. Alright. Same denominator? No. So what is the common denominator? Well, let's see. We'll get back to this. Let's finish this first. Same denominator? Yes. So 2 plus 3, 5, plus 5, 10 over 7. Same denominator? Yes. So then 1 plus 4 is 5. Plus 13 is 18. And that's what you get. Now let's go on to the ones that have different denominators. Same denominator? No. Can I make them have the same denominator? Yes. And this time, I am not going to start from scratch. I'm not going to start explaining. I already did that. So if you need to, if you need an explanation again, you just rewind it and we're good. So 6, 3, and 2. What do they have in common on the times table? That they all, when multiplied by a number, you can always get 6. Look, 2 times 3 is 6. 3 times 2, 6. 6 times 1 is 6. So they all have 6 in common. So let me turn this into equivalent fractions with the same denominator. This one I don't have to touch because it's already a 6. So 3 over 6. This one I gotta turn into a 6. So 3 times 2 is 6. I multiply by 2, so I have to multiply by 2. This one, it's 5. This one is 2. How can I turn that 2 into an 8? I gotta multiply by 4. So 5 times 4 is 20. 2 times 4 is 8. Oh my God, what did I do? Did I make a mistake? Yes, I made a mistake. So what? I'm supposed to turn it into a 6. So I just have to multiply by 3. Okay, so by 3. 5 times 3 is 15. So I'm gonna look. This is a 15, okay? And now 2 times 3 is 6. Cool. Now they all have the same denominator. And now let's see. 3 plus 8 is 11. 11 plus 15 is what? 26. 26 over 6. Can it be simplified? Yes, it can be simplified. Am I going to do it for you? No. But just know that, can you divide this by 2? Can you divide this by 2? If your answer is yes for both of them, then guess what? You can simplify it. Okay. Let me see now. Let's go on to this problem. Okay. Same denominator? No. No, you don't have the same denominator. So therefore, let me see. Okay, here. So you don't have the same denominator. Therefore, I have to find a common denominator. So where on the times tables do all these 4 numbers meet? Well, take 30 seconds and figure it out. Me, I'm gonna drink some water. Do you figure it out? Huh? Okay, let's see. 3 and 4, they have 12 in common. But this one doesn't have 12. 6 also has 12 in common. Oh my God. Okay, maybe 30. 3 times 10 is 30, but 4 times 10 is 4 times anything is not 30. Okay. You know what? How about 60? Can I multiply by something by 3 and get 60? 20. Okay. So let's see now. So this one, I'm just gonna put it over here. So I have, I'm going to multiply this by 20 over 20 to get 60. Can I multiply 4 by something to get 60? Yes. 15 over 15. Can I multiply 5 by something and get 60? Yes. 12 over 12. And can I multiply 6 by something to get 60? Yes. 10 over 10. I hope you understand what I'm doing right now. So that will make all these denominators 60. So let's go right ahead and do it. Okay, if I multiply by 20 over 20, I'm gonna end up with 20 over 60. Correct? 1 times 20, 3 times 20. Okay, and now when I multiply this by 15, and that's plus, right? 15 times 2 is 30 over 15 times 4 is 60 plus, okay, plus 5 times 12 is 60, 3 times 12 is 36, so this is 36 over 60. And last but not least, multiplying 10 by 10 over 10, I get this to be 40 over 60. And now I'm ready to add. So let's see, they have the same denominator. So 20 plus 30, 50. Okay? 50. 36 plus 40 is 76. So 50 plus 76 is what? 126 over 60. Can I reduce this? Sure. What's half of 126? 63. What's half of 60? 30. And that is your simplest form. I don't think you could do anything else with that. Oh no, actually oh no, you can. Let's see if I can divide these two by 3. So 63 divided by 3 is 21. And 30 divided by 3 is 10. So yes, I get 21 over 10. And that's it. I don't think you can do anything else. Awesome. Alrighty, cool. So let's see what's next. So that was our learning intention number 1. Adding, subtracting fractions. Same denominator, different denominator. Boom. Caught it. Oh my God. All full.
It don't matter, it don't matter, it don't matter.
Becker's test. I study that. Regents exam. I own that. Oh! So in the next lesson, we're going to go through multiplication and dividing fractions. Okay? Goodbye.